Hi friends, welcome to my channel Mathematics Idea. This video is also available in Hindi. यह वीडियो हिंदी में भी उपलब्ध है. If you are the first time viewer of this channel and directly this video, then I will suggest you to go through my introduction video first to understand the presentation structure of the course content. Today we are at detailed explanation class 4. Okay, so we are at detailed explanation class 4 for matrices, right? Okay, so before this we had completed the introduction of the matrices and 3 detailed explanation classes. So I want you to go through this series. Okay, first you complete the introduction, after that 3 detailed explanation classes, and after that come and listen this detailed explanation class 4, right? Okay, detailed explanation class 4 is based on the type of matrices. Okay, so there are different type of matrices, right? So how we identify what are those types? Okay, so based on the type of the matrices, this detailed explanation class 4 is made up of. Okay, detailed explanation class 4 is made up of the basics of types of matrices, right? Once we go for the type of matrices, by seeing the matrix you should be able to approach that what type of matrix it is. Okay, so I had divided the types of matrices into 2 classes. One is visual class and another one is operations class. Visual class are those classes by which directly by visual representation you will come to know that which type of matrix it is, like whether it is a row matrix, it is an identity matrix, or it is a singleton matrix. Okay, so such type of what you can say, you can identify that which type of matrix it is. So that type of matrix will fall under the class of the visual class matrices. Another is operations class. Operations class are the such class or such type of the matrices in which you need to first perform certain operations, like here you have done a square equal to a. Unless or until you will perform that operation, you will not be able to find that whether it is that type of matrix or not, like whether it is an idempotent or not. To find that whether it is an idempotent matrix or not, you have to do the operation a square, and after that you have to come up with whether it is equal to a or not. So if a square equal to a, then only that matrix is known as idempotent matrix. Suppose if you want to go for the periodic matrix, then a to the power of k plus 1 equal to a. Okay, you have to find a to the power of k plus 1, like a cube if you would have find. Then 2 is the period of that matrix. A to the power of 3 equal to a, then 2 is the period. K plus 1 equal to 3, so k will be equal to 2. So such type of operations you have to perform to come up to say that this is that type of the matrix, idempotent matrix, or a periodic matrix with period k, or a nilpotent matrix, or an involutory matrix. Okay, so these are the different type of the matrices which can be found by performing the operations. That's why these matrices are kept in the operations class. Okay, right. While explaining these operations classes, I will not take you through the particular matrix. Okay, so examples of the matrix will be given in the notes. You can go through the notes at the end of this class and you will find the example for each matrix, like a square equal to a, then an example of a. Okay, example of a, some matrix 1 0 9 3 5 6, like that. So such type of the matrix examples will be given at the end of the notes. Okay, for operations class. Okay, please follow the notes. Chalo, let's go through this visual. In the type of matrices, I told we had divided it into the 2 classes. One is visual class and another one is operational class. In visual class there are 2 things, one is order and another one is elements. So order, how to find the order? I told in the introduction class itself, order of an matrix is number of rows into number of the columns. So number of the row into number of the column, m cross n. By seeing the order itself, you should be able to tell which type of matrix it is. Suppose 1, 5, 6, such type of matrix. So this is having one row itself, that's why it is known as the row matrix. So row matrix is a matrix which is having number of row as 1 and number of columns as n. So 1 cross n type of matrix is known as a row matrix. Column matrix, a matrix like 1, 5, 6, column is 1, so m cross 1, so column is 1, here row is 1. So whenever column is 1, then such type of matrix is known as column matrix. So these are the certain matrix by which you can get that this is a column matrix by seeing itself, visual. That's why we had kept it into the visual class. Rectangular matrix. Rectangular matrix are those matrix in which m cross n, both m and n are not equal to each other, like 2 by 8 or 4 by 6. Such type of matrices are known as the rectangular matrices. Further, this rectangular matrix is divided into horizontal and vertical. Okay, further this rectangular matrix is divided into horizontal and vertical. I told in m cross n, m is not equal to n. Whenever m is not equal to n, then it is an rectangular matrix like 3 by 4 or 4 by 3. Okay, now how to tell which is horizontal, which is vertical? Whenever number of the columns are more, then that is known as horizontal. If columns will be more, then it will become horizontal, right? That matrix will become horizontal. So that's why when n is greater than m, then it is an horizontal. M is not equal to n, that is for sure for a rectangular matrix. But m is not equal to n, and in that if n is greater than m, then it is horizontal. If m is greater than n, then it is an vertical. Okay, m is greater than n, that means number of rows are more than number of columns. In that case, it is an vertical matrix. Okay, got it? So this is a rectangular matrix. For examples and all, just keep eye on the notes. Okay, I will give the example over there. This is just a theoretical explanation class for the types of the matrices. Next is square matrix. Square matrix is such a matrix in which m and n both are same, like m equal to n. So this square matrix will be like 5 by 5, 4 by 4, 6 by 6, 3 by 3. Such type of matrices are known as square matrix. So these are all by seeing the order. Okay, by seeing the order itself we can tell that which type of matrix it is. Next is diagonal matrix. Diagonal matrix is such a matrix in which only diagonal elements will have values, rest of the elements will have zeros. For example, for diagonal values like this 1, 2, 5, 0, 0, 0, 0, 0, 0. This type of matrix is an diagonal matrix, where diagonal is having a numbers, rest all is a 0. Okay, only natural number will be there in a diagonal. Such type of matrix is known as a diagonal matrix. After that, there is one matrix known as triangular matrix. Triangular matrix is those matrix in which we have to see the elements. So in this we are seeing the elements, like diagonal elements we are seeing, and we are seeing the other elements in which other elements are 0 and diagonal elements are natural numbers. So we are seeing at the element, that's why these are classified under elements. Okay, now so it is a diagonal matrix. Triangular matrix, if you take out these elements from here and you write some 6, 8 and 7, this is a lower triangular matrix. So we can see that lower triangle is filled with an natural numbers. So such type of matrix is known as a triangular matrix. In triangular matrix itself, there are two type of matrix. Triangular matrix. One is upper and another one is lower. So upper triangular matrix and lower triangular matrix. So this is a lower triangular matrix in which lower triangle are the natural numbers, right? Now for upper triangular matrix, these elements will be 0, 0, 0. Here it will be some numbers like 6, 7, 8. Such type of matrix is known as the upper triangular matrix. Just by looking at the elements itself, focusing on the elements, we are coming up that which type of matrix it is, right? So this is a triangular matrix. Another one matrix is very important matrix, which is known as the identity matrix. Identity matrix is a diagonal matrix with a diagonal of 1, 1, 1. So identity matrix is this matrix. So this is an identity matrix. Okay, so this identity matrix is equivalent to 1 in the matrix. Like you will write 2 into 1 equal to 2, right? In our normal arithmetics with our numbers, 2 into 1 equal to 2. Like that for a matrix, A into I is identity matrix equal to A. So this identity matrix is equal to 1 in our matrices. Okay. So this is identity matrix. After that, singleton matrix is a matrix in which there is only one number, like 5, just one number. Okay, just by looking at the one element, you will come to know that it is an singleton matrix. Null matrix. Null matrix is such a matrix in which entire matrix is 0, like 0, 0, 0, 0, 0, 0, 0, 0, 0. So this many zeros, then it is known as a null matrix. Are you getting it? So this is a visual class. So visual class where you can identify different type of the matrices. So there are 4 under the order and 5 under the elements. What are under the row orders? Row matrix, column matrix, rectangular matrix, and after that square matrix. In rectangular matrix, we are further having horizontal and vertical. Okay, whenever m is greater than n, then it is known as horizontal. So then it is known as vertical. When n is greater than m, then it is known as horizontal. Okay, so this completes our order. And in elements, we are having diagonal, triangular, identity, singleton, and null matrix. Okay, so diagonal matrix are those matrices in which only diagonal will have natural elements, rest all will have zeros. Triangular matrix is those matrices in which either upper triangular or lower triangular is filled. Okay, based on that, there are two matrices which is known as upper triangular matrix and lower triangular matrix. So upper triangular is filled and lower triangular elements are zeros, then it is known as upper triangular matrix, right? And vice versa, it is a lower triangular matrix. Identity matrix, it is in the form of 1, 0, 0, 0, 1, 0, 0, 0, 1. Such type of matrix is known as the identity matrix. Singleton matrix, where there is only one element, like 5, that is known as singleton matrix. Another one is the null matrix. Null matrix is a matrix in which it will have all elements as 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, such type of. It is 3 by 3 null matrix. It can be 4 by 4 null matrix as well. Okay. Chalo. I will rub this out and after that we will go through these operations. Okay. Chalo. Now let's start the other type of the classes, which is known as the operations class. So by operations class, we have to perform the operations between two matrices. Otherwise, we can't tell that which which type of matrix it is without performing the operation. This is not just the visual representation that by seeing the order or by seeing the elements itself, you will come to know that which type of matrix it is. So this is an operations class. Okay, right. So first is idempotent matrix. Idempotent matrix is such matrix in which A square equal to A. Suppose A is a matrix, you just square that matrix, and if you will get the same matrix again, then such type of matrix is known as idempotent matrix. Example, I can tell that identity matrix right now. Otherwise, you can go to my notes for the examples for each of them. Okay, in notes examples are provided. So if I will take identity matrix, I will square the identity matrix, I will get again the identity matrix. Okay, so that's why I is one type of a idempotent matrix. Okay, that is one of the example. Next, periodic matrix. Periodic matrix are matrix in which A to the power of k plus 1 is equal to A. If suppose there is a matrix A, I will do A cube, then 2, and I will get A as the answer, like A cube I will do, and it will result me to A. Okay, answer is A. Then my period of that matrix will be 2. K plus 1 equal to 3, so K will be 2. So A to the power of k plus 1 is A, in which K is the period, right? So that is known as periodic matrix. Another one matrix is nilpotent matrix. Nilpotent matrix is a matrix in which A to the power of k is 0. If I will take one matrix A in which A cube is 0, and provided that A to the power of k minus 1 is not equal to 0. This is the must condition. It's not that you are taking a 0 matrix and you are getting 0 afterwards. Or you are taking some matrix, suppose for a matrix A cube is 0, and again you are getting A to the power of 4 is also will be 0, because again it will be multiplied with a matrix A itself, right? So you are getting A to the power of 4 0, A to the power of 5 0. So that is not the right way. So that's why, provided that A to the power of k minus 1 is not equal to 0, then A to the power of k is 0, then it is a nilpotent matrix. Are you getting it? If suppose you are getting A to the power of 3 as 0, okay, then definitely your A to the power of 4 will be 0. A to the power of 5 will be also equal to 0. So whenever you are getting some A to the power of 3 equal to 0, then you have to make sure that whether A square equal to 0 or not. If A square is not equal to 0 and A to the power of 3 equal to 0, then nilpotent matrix A to the power of 3 equal to 0 satisfies. Okay, this is known as nilpotent matrix. Another one is involutory matrix. Involutory matrix is those matrix in which A square will become identity matrix, A square equal to I. Okay, just you go through for examples, go through the notes, you will come up with the matrices. Okay. Another one is A transpose equal to A. Such type of matrix is known as symmetric matrix. Like a transpose we had already discussed in the detailed explanation class 3. You can go through the detailed explanation class 3 notes, and you will come to know that whenever a matrix in which transpose we will come up with a matrix of A, same matrix, then it is known as a symmetric matrix. A transpose equal to minus A, then such type of matrix is known as a skew symmetric matrix. Okay, symmetrics is A transpose equal to A, and skew metric is A transpose equal to minus A. Okay. Another one matrix is A into A transpose equal to I, that is known as the orthogonal matrix. So what is the orthogonal matrix? Orthogonal matrix is a matrix in which matrix into matrix transpose, it will give identity matrix. Such type of matrix is known as orthogonal matrix. Next is Hermitian matrix. Hermitian matrix is A to the power of theta is A. What is theta here? So A to the power of theta means, first, this Hermitian matrix is always for a complex numbers. Okay, so complex numbers you can find the conjugate and you can find the transpose. Okay, so this theta represents conjugate of a matrix, and after that transpose. We will first find the conjugate, and after that you do the transpose. That is known as this A theta. After doing this operation, if you are getting again the matrix A, such type of matrix is known as the Hermitian matrix. If same operation is performed and you are getting minus A, such type of matrix is known as the skew Hermitian matrix. Okay. After that, at last, whenever a matrix is there in which its determinant is 0, such type of matrix is known as a singular matrix. Okay, a matrix whose determinant is 0 is known as a singular matrix. So these are the certain type of the matrices for which we had done certain operations to come up to find which type of matrix it is. Okay, to find which type of matrix it is. That's why these are operation class type of matrices, where you have to perform certain operations to find its type. Okay, this completes detailed explanation class 4, which is based on operations of the classes. Okay, for further classes, stay connected. Thank you.